Hi folks, we're going to take a look at this question from the homework. So they give us these two functions, and we notice that they're quadratics, but they both have an unknown parameter. So here the coefficient of x squared is unknown, and here the coefficient of x is unknown. All right. So first of all, when I'm looking for two unknowns, I should be expecting to solve a system of equations, and I should expect to be getting two pieces of information to solve for those unknowns. Now they do give us two pieces of information, these 2 points, and these 2 points are on this combined function where we're multiplying f and g. All right. So let's see if we can figure out what those unknown parameters are. So first of all, I'm going to be working with h at x because that's the information that's given to me. And what I'm told based on this here is that h at 1 is equal to negative 40. All right. So what is h at 1? Well, I'm just going to be inputting 1 into the product of these two functions. All right. So f at 1 is going to be m times 1 squared plus 2 times 1 plus 5. All right, times g, which is 2 times 1 squared minus n times 1 minus 2. And of course, all of that is equal to negative 40. And so what I have now is an equation that contains both m and n. So let's simplify here. So this is just going to be m. Okay, here we're going to have 2 plus 5 is 7, so plus 7. And here we have 2 minus 2, so these two cancel out. And so I'm just going to be left with negative n equal to negative 40. Okay, now the first thing I notice is this is not a linear equation. So while we are going to have a system of equations, it looks like it's not going to be a system of linear equations. So we're going to have to see how we can possibly solve this equation. Now I'm going to leave it as is because I don't know that I want to start combining the m's and n's together. So I'm just going to leave it like this, a little simpler. Let's see what happens when we input the next point. So here the next point tells us that h at negative 1 is equal to 24. Whoops, 24. So let's put in negative 1 into the product of these two functions because that's what h of x is made up of. So f at negative 1 is going to be m times negative 1 squared plus 2 times negative 1 plus 5. All right, and then g is going to be 2 times negative 1 squared minus n times negative 1 minus 2. And all of that is equal to 24. Okay, so let's simplify again. So this negative 1 squared is still just 1, so that's going to be m. And here I have negative 2 plus 5, so that's plus 3, so m plus 3. And here I see that this is still going to be equal to 2, so 2 minus 2 is still 0. These two still cancel each other out, but instead I'm going to be left with positive n, okay, equals 24. All right. Now, what I have here is I have two nonlinear equations, both with n and m, and I don't see any way that I could do an easy elimination, but I certainly could do a substitution. And you'll often find that when you're working with nonlinear equations, you tend to use, not exclusive, but you tend to use substitution more than you do elimination. So what I'm going to do is I'm going to isolate the easy one in both of these equations. The easy one to isolate is going to be this n. So I'm going to isolate n in equation 1, and I'm going to do it in equation 2, and then I'm going to equate them. Okay, because it's the same n in both of these equations that I've gotten here. So let's start with the number 1 here. So if I isolate n, okay, I've got my negative 40, okay, divided by m plus 7. And then, of course, I'm going to divide both sides by negative 1, so that'll just make that positive. And then from the second equation, I've got that n is equal to 24 over m plus 3. And of course, these two are the same. So if these two are the same, then these two expressions are also going to be equal. And what this allows me to do is it allows me to set up an equation that contains only one variable. In this case here, the m. All right. And I recognize this as a rational equation. And how do we solve rational equations? Well, best way is to multiply both sides by the lowest common denominator. So I'm going to multiply both sides by m plus 7, m plus 3. So here, the m plus 7 is going to cancel out. I'm just left with 40 times m plus 3. And then here, I'm just left with 24 times m plus 7. Of course, you can also think of it as cross-multiplying this equation. All right, and now this is a pretty easy equation to solve. So we've got 40m plus 120 equals 24m plus, so 7 times 20 is 140 plus 28, so 168. And so here, nice and easy, let's bring this to the other side. That's just going to be 16m equals 168 minus 120, so that's going to be 48. And 48 divided by 16 is just 3. And there we have it. We have our first unknown. All right. And now let's solve for n. Of course, I only need to use one of these, but I'll use both just as a check. Okay. So let's start with the first equation, 40 over m plus 7, so 3 plus 7. So 40 over 10 is 4. And if I use the other equation, n equals 24 over, again, m is equal to 3 plus 3, and 24 divided by 6 is also 4. All right. So here we have our second unknown. All right. Now, if you look back at the actual question here, they actually are asking us to determine the functions f of x and g of x. So we should give the final answers as the function, okay, f of x. So here, what were we missing? Well, we were missing the m value, which we just determined was 3. So it's going to be 3x squared plus 2x plus 5. So 3x squared plus 2x plus 5. And then g of x. All right, let's take a look at that one there. It was 2x squared minus n, which we just determined was 4, so minus 4x minus 2. So it's going to be 2x squared minus 4x minus 2. And there's our answers. All right, so let's do a recap here. So right off the bat, like I said before, when I see that I'm looking for two unknowns, I should be expecting to solve a system of equations, and I shouldn't be surprised that I'm being given two pieces of information. All right, except the information I was given was not about the individual functions f and g, it was about this combination of functions. So I just inputted my x and y values, and I was able to create two equations in m and n. They happen not to be two linear equations, but I was still able to use substitution. So in each equation, I isolated the same variable, and then I just equated them, creating my equation, in this case here, with only the variable m. All right, so that's it for this one.